Hello everyone and welcome back. So if everything goes smoothly, this should be the last video in session 2 of Lee's research and development with the new terrain system. So Lee, we're talking at the very end of this last video about the scrolling section with scroll up, down, left, and right. For anyone who happened to have missed the end of that video, go ahead and give a quick explanation one more time of what needs to be done, and then let's get to it.
All right. Well, if you've been following up to this point, you've seen that we've implemented a list called patches to remove. This is a list of patches that every time we scroll gets patches added to it that are being flagged for removal in a sequenced or time delayed fashion. Now, because we're going to be delaying the removal of those patches, it is completely possible for the player to decide to turn around, backtrack the way they came, and run back into those patches that are now queued for destruction. Now, we could let those patches continue to be destroyed and create new patches over the top of them, but that's a bit inefficient. So why bother? If we've already got the patches in memory, we haven't destroyed them yet, why not tell the system to hold up, don't remove those patches, take them out of the list, and instead of creating the same patch over again, we'll just tell the system, okay, hey, we've got these patches, we're not going to destroy them, we're going to keep them, you don't need to make a new one, and just skip it. That's the focus of this video.
Okay.
So to do it, what we're going to do is we're going to start and pick on our friend scroll up. The process is the same for all four, we just need to change some of the numbers involved. But we're going to pick on Mr. Scroll Up here. So we're going to make a new var, we're going to call this patch. We're going to hit train patch, and I want to call a method called find patch. But you're going to notice we don't have a method called find patch. So we need a method called find patch. So let's jump back over to train patch and let's create it. Now there's not a whole lot to this method. So
I don't know if you're on your
what's that?
computer or mine.
No, I'm on yours. See
Oh,
train
okay.
patch.
Okay.
But I had to bring up my notes, so I jumped over to mine.
Okay.
It's like going, I'm good, but I don't have every line of code memorized. I so wish I could do that though. But so we're going to make a new method. This is going to be a static method. There's no point in keeping it individual. This is going to be, so it's going to be a public static. It's going to return a train patch. We're going to call this method find patch. And what we're going to pass into it is going to be a vector2. We'll call it offset. And inside of this method, we're going to say for each, will it work? Yes. For each train patch in patches, we're going to check to see if terrain patch dot offset equals offset. If that is true, then we're going to return the terrain patch. So that handles the true condition and it's going to break us out of that loop. If we get through that entire loop without ever finding it, we need to return null. So now we've got a find patch method defined for train patch. So we can come back here, go to scroll up. We now have our find patch. We need to send in our offset. So jump back to my notes. Luckily for us, our offset is going to look an awful lot like what we have here. So I'm going to copy this. I'm going to paste it inside of here. But if you remember, we're looking for a vector2. So we're going to change vector3 to a vector2. And we're going to delete the y component here. So we're going to send in the same thing that we're doing for our terrain patch here. Now we're going to check to see if the patch that gets returned is equal to null. If it is, that means we weren't able to find the patch inside of our terrain patch list. So we're going to create a new one. However, if for any reason it does find that patch, then we need to go to our patches to remove and make sure that that patch is not inside of that list. Because if it is, we need to tell it not to remove the patch. We need to put a stop to that. So what we'll do is we'll go patches to remove dot remove patch. Helps if I put it inside of brackets. Okay. So once again, all we're doing is we're going, okay, I'm about to scroll up. I need to create a whole row of patches for each new patch that I'm looking to create. Go and see if that patch exists. If that patch is already in memory, then there's no point in creating it, and go and make sure that it's not flagged for removal. If it's flagged for removal, stop the removal, and we're going to reuse that. But if that patch does not exist, we're going to create a new one. The same principle is going to apply for all of the other scroll methods. So I'm just going to copy and paste all this for each one of these. And then I've got some cleanup work to do. So for scroll down, I'm going to take this method here, cut it from there, paste it there, cut this one, paste it there, cut this one, just to make sure that I don't forget those. Now for scroll down, we're using our X and Z, so these ones stay the same, but for scroll left and right, these are different. So I need to remove this part and that part, and I need to add this to both of these. We can build it, and now what should happen when we run, and Jason's going to demonstrate this for us, is he's going to run to a point where new patches are created. Then as soon as the patches start getting created, he's going to turn around, run back to the point where they should delete, and hopefully any patches that were being deleted get stopped.
You think it's going to be fast enough?
Well, it should be.
Whoa.
Oops, I hit Control P. Sorry, my bad.
Oh, it's all good.
I was just hitting it just to make sure it was built.
Yeah, it's all good.
Well, what will happen is as soon as you find the position where it's starting to create new patches, stop, turn around, and walk backwards across that line.
Yeah.
Because it should be interesting. What will happen is you'll start adding those new patches. You'll turn around. Those patches will continue to be created, but the patches that were going to be destroyed won't be. Okay, so turn around and run back the other way. Faster.
That's what I was saying.
Okay, good. So the patches that should have been flagged for removal never got removed, but the ones that were just created got removed instead.
Hang on, let me do this. There we go.
So here, let me take the mouse if I can. All right.
Okay.
As you're running, you'll notice that new patches are being created here because he's running and crossing that threshold. So it's adding patches here. when these patches are being added here, these patches, and hopefully you can see the mouse moving, are
Yeah.
flagged for removal. So it's saying, okay, we need to add patches here, but we should be removing these 3 patches. But when you turn around and run back, it's saying, oh, okay, add these patches and remove these 3 patches that I'm currently creating. So it will create and remove these patches. These patches will be removed from the list because they're still there. So they'll never be removed. But these patches, because you've crossed that line, will be removed again.
Okay. Let's go ahead and jump back in there. And turning around, running back the other way. And we never had those removed. Turn around, run back the other way. Woo. A bit faster on the turn, run. Yeah, it looks like it's working. I'm lost now. I got all mixed up.
And you've only got 9 tiles.
Yeah, I know. Yeah, but we're stressing my poor system here.
That's true.
Really
it's
bad.
getting old.
Yes, I know. We've already gone over that earlier tonight.
Many times.
Yes.
But it's so much fun to point out.
I know. 3 generations behind. 3.5. All right, fantastic. Okay, is this pretty much where you wanted to call it for the end of session 2? Keeping all
Right.
this as a kind of a somewhat concise look at where you're at, not getting into the next large topics such as sculpting or multi-threaded systems.
Right. This is just the functionality. There are some optimizations in it. Yes, there are a lot more optimizations that could be done.
Optimizations?
But yeah, that too. Well, it's after 6 now.
Yeah, that's true.
But there's a lot of things that could be done to clean up this code and make it more efficient. And but it is R&D code. The whole point of this is to test a concept to see if it's viable and to get it done as fast as you possibly can to prove that point. Not so much to write the terrain system that's going to be used for the MMO for the duration of the entire class.
Right. All right. Well, so far so good. Well, I guess we can go ahead and wrap it up here. A giant thanks to everyone out there that followed along with you all the way up to this point here.
Yep.
And now I can say that we've got some other videos that we may be putting up where Nelson and you had discussed a little bit about storage the other night.
Right.
And go ahead.
I was going to say, and there's some things in there. See, we kind of discussed some stuff, and that made me think, and I went back and I've modified the code a little bit between those videos and the videos that you got to see. So if there's anything that you noticed that's a discrepancy there, that was just something that we've modified since then. It's no big deal.
Yeah, exactly. All right, fantastic. Well, again, thanks a lot, everyone, and that is going to wrap up session 2 of the research and development for the new terrain system. Thanks a lot, everyone.